Example 3, finding the mean, variance, and standard deviation. The table describes probability distribution for the number of females in 2 births. Find the mean, variance, and standard deviation for the probability distribution described. So, the first thing we're going to do is we're going to create a table. So that table is the following. Okay, we know that we have the data value x, which represents 0, 1, and then 2. And we have the probability of x, which is 0.25, 0.50, and 0.25. Then we have this column here, so we need to take the data value and then multiply it by the value of the probability of x. So we're going to do that. So the data value, which is x, and then we're going to multiply it by 0.25, which gives us 0.00. Okay, then we're going to do the next. We're going to take the value of the data value of 1 and then multiply it by 0.50. So 1 times 0.50 is going to give us 0.50. And then we're going to take the data value of 2 and then multiply by that by 0.25. So 2 times 0.25 is then going to give us 0.50. Now, the 2 columns on the left, at the left, describe the probability distribution, which is what we have here, right? And the 2 columns at the right are for the purposes of our calculations required. So what we want to do is we want to find the mean, meaning that to find the mean, okay, we need to find the sum of this column, meaning that we need to add this entire column. So if you come down here, you will see that when we add 0 plus 0.5 plus 0.5, we get 1. Therefore, the mean is going to be 1. So now we know that the mean is, again, is the sum of that column, and therefore we found that to be 1. Okay, so let's go ahead and write that down. So the mean here is 1 by adding 0 plus 0.5 plus 0.5, and therefore there is our mean. Okay, now the fourth column here is that we need to take the data value of x, and then we're going to subtract what we got for the mean, and then we're going to square it and then multiply it by the probability. So let's take a look here. So we have our data value of 0, and then we're going to subtract the mean that we got. We're going to square that and then multiply it by the probability of 0.25. So just to show you real quick here on the calculator, if I wanted to do that, we would say the following. We would have parentheses 0 minus 1.0, and then we square that result, and then we need to multiply that by 0.25, and that gives us 0.25. Now let's do the same thing for the next one. Okay, we're going to take again the data value of x, which is 1, and then we're going to subtract the mean. We're going to square that and then multiply it by the probability of 0.50. Well, 1 minus 1 is 0, and 0 squared is 0, and 0 times 0.50 is going to give us 0. Again, we can verify that on our calculator. We got 1 minus 1.0, okay, and then we square that, and then 0 times anything is always going to give us 0, so it gives us a 0. Okay, next, we take the data value of 2, and then again, we're going to subtract the mean that we found in the third column, square it, and then multiply it by the probability of 0.25. Well, 2 minus 1 is 1, and 1 squared is 1, times 0.25 is going to give us 0.25. Okay, so now what we want to do is we want to be able to find the variance. So the variance is adding up this entire column. So if we add this entire column, then we're going to get the following. Okay, so the variance is we're going to add 0.25 plus 0 plus 0.25. And then down here, you can see this is what the variance gives us. When we add that, we get 0.50. So the variance is going to give us 0.50. Okay, now we need to find the standard deviation. Now recall that the standard deviation is the square root of the variance. So let's take a look at that. So to find the standard deviation, okay, we're going to do the following. We're going to take the square root of 0.5, which then gives us the value of 0.0707, rounding it to one decimal place gives us 0.7. And there is our standard deviation. So now we've been able to find the mean, the variance, and the standard deviation of a probability distribution. So let's go ahead and then take a look at this here. So in the table, we used the mu, which is equal to 1.0. Now, if that mean had been the value of 1.23456, we might round mu to 1.2, but we should use its unrounded value of 1.23456 in the table calculations. So in here, instead of being 1.0, if it was 1.23456, we would have used that number in here instead. If you round in the middle of calculations, it can lead to results with errors that are too large. So do not round until the very end of the problem that you're working with. Now the interpretation is the following. If in two births, the mean number of females is 1.0 female, the variance is 0.5 female squared, since it's a squared unit for the variance, and the standard deviation is 0.7 female. Also, the expected value for the number of females in two births is 1.0 female, which is the same value as the mean. If we were to collect data on a large number of trials with 2 births in each trial, we expect to get a mean of 1.0 female.